Problem 38 is a classic Pythagorean theorem problem if you're asked to find one side of a triangle that's a right triangle. Then you should be thinking about the Pythagorean theorem right away. So the important part to make sure that you're looking at is that you know which side of the triangle you're trying to find. So in this case, the right angle connects the two legs. So I know I have a leg and a leg. And just a reminder of the Pythagorean theorem just says that if I have a right triangle and I have a leg we'll call A and another leg we'll call B, and then the hypotenuse, which is the longest side, always opposite the right angle, then if I take A squared plus B squared, in other words, I square this length and I square this length, then I get the square of the hypotenuse side. So in other words, if I take a square out here and its area A squared, and I take a square out here and its area B squared, then I get the area of C squared, so that side squared. It doesn't give me C, it gives me C squared, and this is where oftentimes mistakes are made with a problem like this. So I'm going to go ahead and, realizing I have a leg and a leg, so I can take 5 squared plus 12 squared equals C squared. So 5 squared, 5 times 5 is 25, plus 12 times 12, 12 squared is 144, equals C squared, which is 169. And so now I have C squared, but I don't have C, because what I have now is the area of the square of the hypotenuse. And to find the length of the side, then I need to take the square root of 169. In other words, the square root of C squared is equal to C, which is 13. Square root of 169 is equal to 13. And so that side of the triangle length is actually 13. A squared plus B squared equals C squared. 25 plus 144 equals 169. So you can't just add the 5 and the 12. You need to square them and then find the square root of the sum of those sides.